Hi, welcome to my project presentation for CS 5590 final project for the AI cybersecurity class in spring 2022. So, the main goal of my project is to apply differential privacy on age, gender, ethnicity prediction. So, I have used to give you a very high level overview. I have used a CNN architecture and the using the CNN architecture I constructed a multi-output model, meaning I am predicting age, gender, ethnicity jointly in a single run. That saves a lot of time and adds efficiency to the training process. In the first trial I have done it using simple Adam optimizer, the vanilla uh, stochastic gradient descent or Adam optimizer. As a second step, I applied the differential privacy and studied uh, the the variation of accuracy, studied the accuracy with the privacy, the privacy budget epsilon. That's the main goal of my project. So why I'm pursuing that? The main reason is that from the vast amount of literature that I have researched so far, I've seen that there have been attempts to apply differential privacy and study the effect of accuracy, different factors, but everything was done either a single type of image like MNIST, the digits images, or even for UTK faces, they have done only for the the single variation, single target, like either age or gender, or age plus gender, sorry, either ethnicity or gender, or age or gender, I mean one variable at a time. But in this study, actually I've never seen that somebody has studied the multi-output model, because they are slightly different from the traditional models. So that's what I've studied here. So this is a new thing that I've added to the existing efforts. So so first of all, I have used the data from a Kaggle challenge here, as indicated in the class. I have sourced the data from Kaggle, uh, and then also this data is based on the images the from UTK faces, which are the human faces. So to uh, to describe it a very high level, I will show two uh, training passes. Number one is based on simple CNN model without any privacy added to that, and as a second step, I will add the CNN model and applied privacy on that. I chose TensorFlow as my technology choice. So as a first step, I installed the TensorFlow privacy. Uh, and you can see here, I mean, there was some version conflict, which is not new with the collab, and I restarted the runtime to correct it, to make the new libraries effective there. Then I installed some useful libraries, and finally I mounted my data on I put the data on my Google Drive and mounted the Google Drive. So I started looking into the data. Let's go to the interesting part. So here you can see that from the data itself, without doing any privacy, anything, nothing. So I have found that the data is like that. I mean, like it has mostly uh, data from the lighter screen, but some data from not lighter, darker screen people. So there is kind of imbalance in different classes here as far as the ethnicity goes. Secondly, the gender, you can see about 52% male and 47% female. faces within the data set, slight imbalance but not much. Then age distribution, you can see the most of the majority of the data contains age between 20 to 40 years old. And finally, you can see the age distribution. Y- so here it is quite evident that 20 to 30 contributes the most, and then 30 to 40 is kind of second largest, and then 40 to 60 also same proportional. But then the lower age and higher age are less. So finally, so this is so once we get the data, mm, I I simply applied a train test split of 70 per 0.7, and then constructed the data. Pre-processed the data set for our uh, further model training. So created a data generator in this way, and basically I generated the data in these factors, the images, and then the three target variables: ages, races, and genders. These are the three features I've added to the data set. So finally, you can see I have constructed the data set, and this is the basically the size of the data set, train data set plus the validation dataset plus test dataset. So basically, our train dataset have 11,615. The validation has 4,978, and test dataset, which is not touched during the training and validation process, this is 7,000. So finally, I go to the build the model. So this is an output multi-output model. There are three branches: gender, age, and ethnicity. Each branch contains a sequence of convolutional layers that is defined on the make default hidden layers method. So this is that method. You can see I have used convolutional, and then convolutional layer. Then there is an ReLU activation, batch normalization, and then max pooling 2D, and finally the dropout layer. The ethnicity branch has some specialization in it. I use the ReLU activation, but also I have used near the output, I have used the softmax optimization, activation function. The gender branch, I have used the sigmoid, which is kind of the s- I mean, which is consistent with its binary pattern, like male or female, and this is the classification pattern softmax is used. And then the age branch, this is kind of regressional pattern, so I've used a linear activation function for age. So finally, I combined the full everything into a full model, and my definition of my model is like that. So I created an instance of the model. Then comes the interesting part. I compiled the model, use the Adam optimizer. So I have used for age the mean square error as the loss variable. For gender, it is the binary cross entropy, and loss for ethnicity is categorical cross entropy. Binary accounts for the binary nature of the data. Everything is sensitive to the nature of the data itself. So finally, I compiled the model, and then this is the picture of the model you can see. Uh, so that's about it. And then the model also summarized here. So you can see there are 242,664 parameters. Trainable parameters are 241,416. And then finally, I trained the model. Uh, I set a batch size of 64, and epoch number of epochs is 100. Created the model checkpoint, and monitoring the validation loss. So once I completed it, this is the accuracy plots. Like for ethnicity, you can see it goes up to like slightly more than 80% ethnicity uh, maximum. And then the gender estimation is better. I mean, here it is. So the training data set, it's about like 98% 98% uh, efficiency uh, and the accuracy. This is the mean absolute error. You can see it goes down up to like 10% level. And then overall loss is, you can see for training, overall loss is very low. So 0.8%, 9%. These are the best values. So on the test data, then I evaluated the model, and I got this classification report and accuracy score. You can see that. Let me show you. This is for the ethnicity. So you can see that F1 score is for white, black, Asian, Indians, and others, with a overall accuracy of 0.77, 77%. For gender, it's 89%. So overall accuracy, you can see 76% for 77% for ethnicity, and gender is 89%. And finally, the age, I plotted the predicted age versus actual age plot, and you can see R2 score is zero point 0.7. The mean squared error is 116, and the MAE, mean absolute error, is 8.28, which is not so bad. Um, so finally, what I did is that I tried to study how I mean, in order to make more sense about the age, the learning curve for the age, I made these plots. So here you can see that I have fitted the histogram for um, different age beans, like you see 0 to 10, 10 to 20, 20 to 30, I mean, so on. But what I added there is the true age minus predicted age. So the difference, ideally that should be 0, but you can see the means here, and I fitted those with the Gaussian uh, with the Gaussian distribution. And then this is the mean, and there is sigma 7.81. And then what I found is that I calculated the overall accuracy for like within the different age beans. I have calculated the number of positives, number of positively identified pictures, and then overall accuracy comes up to be 66%. And then for different ethnicity classes, like for whites it is 77%, and I mean for non-white it is 58%. So there is a disparity between the identification process. In the identification process, I plotted the age versus mean age. You can see it here. The mean is low for this particular data point, which is close to 15 years of old. The sigma, you can see the lowest for between 20 to 30, which is justified because we have the most of the statistics between that data bin. And then finally, I these are the predicted. I made some predictions, so you can see there. There is, for example, there is a difference between predicted and actual. So then finally, I'm going to the privacy. So for the privacy, actually, I had to make up the privacy optimizer class because TensorFlow privacy, uh, the latest version of the TensorFlow privacy doesn't work well with TensorFlow 2.8, based on the feedback from TensorFlow forum, I just added this patching code. They have provided it, so they are working on fixing the TensorFlow itself, so that this optimizer class works with the TensorFlow. So they gave us the code patch, so I've applied that. So you can see I've used Gaussian optimizer class. Basically, I'm folding the each of the each of- in each step I have folding the gradient descent with the Gaussian noise. So that's part of the process, which is uh, applied to make sure that we are composing the differential privacy all through the model, not just one part of the model or one layer or one part of the model. So this is a compositional feature of the differential privacy. And finally, this is the way to calculate the epsilon, the privacy budget. And you can see I've used delta is equal to 10 to the power minus 5 because we have 12,000 training data points. So finally, I used this gradient descent optimizer and basically very low learning rate. I found that if I change the learning rate, the fitting doesn't look pretty good. So I applied a noise multiplier to be 7. There are 4 parameters that I've used: noise, norm clip, noise multiplier, number of micro batches, which is the same of number of batches, and the learning rate. So finally, I came up with the fitting, and these are the uh, performance. The ethnicity estimation accuracy, it is less than what we saw in case of the CNN model without any privacy. So then gender estimation looks like this. It drops significantly, and then the this is the overall loss estimation. It is more, training data shows more losses compared to the no privacy model. And then the important thing is that I can show you uh, that these results. I mean, I've done everything similar, but here you can see if I use no differential privacy versus differential privacy, uh, you can see these models, and you can clearly see that with addition of differential privacy makes the error larger, mean the sigma larger for each of these Gaussian beans fittings. So if I see the accuracy, you can see 72% for ethnicity, gender is 70%, which is significantly lower than the respective numbers from no uh, privacy model, because I have applied very low epsilon, means very high privacy. So, and then overall privacy drops to 47% compared to 54% for 64% for no privacy situation. But you can see the ethnicity classes for different ethnicity. You can see that white and non-white classes, they are also differed. Like white, 51% accuracy is for white people, and non-white people it is 45%. So uh, kind of similar, looks similar, but there is difference, there is a disproportionality. So the results are somewhat sending same trend, I mean showing the same trend as the previous works on uh, single output models by other authors. They were showing that differential privacy has disparate impacts on the model accuracy. So that's what I've done for this project, and there is more to come in the project report as well as my presentation. And I have committed my GitHub, my code to the GitHub repository. It looks like this. So this is my this is the final project. So I can show you the GitHub repository. It looks like this. I will get rid of this. Made more studies, like I put extreme numbers, extreme values for noise, like 50, which is, I mean, which accounts for differential privacy epsilon of 2.2, and also zero point 0.7 noise, that is about uh, that is privacy of 10, which is pretty low privacy, to cross validate the results. So those were part of the studies, but the best results I've got from this following uh, file. I will add some description in the project and make it available. This is a public repository, so you can take a look. I have put this repository reference in my project paper. So that's all about the project, and thank you very much for listening to it. Talk to you soon.